Hi, hello, welcome to Lenvis. It's me, Linus. Hope you are doing well. Have you enjoyed the last video? Thank you so much for your support and your comments and views and shares are great motivation for me. Thank you and thank you once again. Yes. So in this video, we will be discussing about the PYQs of Class 12 Board CBSE, the upcoming exams. Okay. Past few years, 2024, 2023, 2022 question papers, organic chemistry we are going to discuss. Okay. Yes. So kindly go through all the questions. Okay. Any doubts you can ask, you can comment. If you want more question papers to discuss, please share your comments. Okay. Yes. Yes. Moving to the first question. Yes. N and diethyl benzene sulfonamide is insoluble in alkali. Give reason. Okay, when you see this question, which chapter should be coming to your mind? N diethyl benzene sulfonamide. So yes, of course, it's a question from amines, right? Amines. N when it comes double N, so you understand it's like a tertiary, right? Yes, there is no hydrogen atom in that N. Okay, so we understand that benzene sulfonamide. So we have studied a reagent named this. What is that reagent called as? It is called as Hinsberg reagent. Hinsberg reagent, right? What is Hinsberg reagent? It is benzene sulfonyl chloride. Benzene sulfonyl chloride. So that is Hinsberg reagent. What is the use of this Hinsberg reagent? Yes, it is used to distinguish what? Distinguish primary, secondary and tertiary amines. So that is the use of Hinsberg reagent. Okay. Now this is the second step. Okay. N diethyl benzene sulfonamide. So how will you prepare N diethyl? So it will be a secondary amine, right? So just take a secondary amine. Okay. First of all, we will write the benzene sulfonyl chloride. So its structure will be like this. Okay, benzene sulfonyl chloride. Okay, and it is reacting with what? Reacting with, I told you that secondary amine, right? Diethyl, right? Diethyl means secondary amine, C2H5 and C2H5. So what will happen here? You will be getting this HCl will be removed and you will be getting this one. N diethyl benzene sulfonamide. Okay, that is the product here. So S double bond O, then comes N C2H5, C2H5. Okay. So now you, from this structure, it is very much clear that this nitrogen atom contains no hydrogen, right? It is having no hydrogen, so it is not at all acidic in character. So when you add alkali, what will happen? This is a precipitate. Okay, precipitate formed when this Hinsberg reagent is treated with what? Hinsberg reagent is treated with secondary amine. A precipitate will be forming and this contains no hydrogen atom in nitrogen. So that means it is not at all acidic in nature. Yes, so it is not at all acidic. So this will be insoluble in the alkali. Okay, so basically Hinsberg reagent is used to distinguish between primary, secondary and tertiary amine. If it was primary amine, what will happen? There will be NH here, right? So it will be soluble. So in the case of primary amine, the precipitate will get soluble in the alkali. In the case of secondary amine, precipitate will form, but since it is not acidic, since it is having no hydrogen in nitrogen atom, it gets insoluble in the alkali. And what about the case of tertiary amine? Tertiary amine have no reaction because tertiary amine having no hydrogen atom, right? So it does not react with Hinsberg reagent. Okay, so that is the test for this. Okay, very important. Yes. Next question is aniline does not react with, means does not undergo Friedel-Crafts reaction. Okay, just write down the aniline structure, benzene ring and NH2. This is aniline. And we know that Friedel-Crafts reaction which is the main catalyst we are using? Yes, we are using anhydrous aluminum chloride. And anhydrous aluminum chloride is a Lewis acid because it lacks electron pairs, right? Electron pair acceptor, this one. Okay, here nitrogen is there in the aniline and it is having lone pair of electrons, right? So this will act as it's a basic, right? So it will react with this aluminum chloride. Okay, what is happening is that when aniline react with aluminum chloride, they will form a salt. Okay, NH2 AlCl3. So this will form a salt. That is why aniline is not undergoing Friedel-Crafts reaction. Hope you get it, right? Yes. Moving to the next question. Write down the reaction involved in Gabriel thalamide synthesis. Okay. So when you hear the word Gabriel thalamide synthesis, okay, what is that synthesis for? It is for the preparation of amines. Okay, it's for the preparation of amines. And what type of amines? Yes, primary amines. Okay, and primary amines, one more point you have to note down here is that primary amines only aliphatic primary amines. Aliphatic primary amines. Okay, yes. Now let us move on to the synthesis. You have to write down the synthesis, right? So Gabriel thalamide. So we have to take a thalamide. So thalamide is the amide of phthalic acid. Okay, C double bond O, C double bond O, NH. So this is thalamide. And first of all, we have to make it react with what? Make it react with the potassium hydroxide. Okay. So this H will be replaced by what? H will be replaced by this potassium K. Okay. In the next step, what will happen? In the next step, we are adding alkyl halide. Okay, RX. So, yes. So, H instead of that K, yes, it will become NR. Okay, NR. That is N alkyl thalamide. Okay, N alkyl thalamide. Okay, so when it is treated with alkali NaOH, you will be getting what? Primary amine RNH2 along with what? Plus salt of this phthalic acid. Okay, salt of this phthalic acid. C double bond O, C double bond O, ONA plus, ONA plus, salt of this phthalic acid. Okay, yes. So primary amine preparation. So Gabriel thalamide synthesis is a synthesis that is used to prepare amines. Basically, primary amines, only aliphatic amines it will give. Okay, no aromatic amines cannot be prepared by Gabriel thalamide synthesis. Yes, and you will be getting this primary amine. Okay, yes. The synthesis is directly asked in the question. Okay, yes. Next question is, how will you convert aniline to para-bromo-aniline? Okay, very simple. Para-bromo-aniline. You have to prepare. So, just reactions, right? Electrophilic substitution reactions of aniline. So, NH2. This is aniline. And we know that aniline has 2. So, this group is special, right? So, we have to protect that aniline group. NH2 group. So what you have to do? You have to add acetic anhydride. Okay. So the group will be first protected. NHCOCH3. After that, we are adding bromine. In the presence of acetic acid, CH3COH, you will be getting what? Ortho para product. Basically, para will be what? Para will be the major product. Yes. Okay, you will be getting para bromo. Yes. Then what you have to do? You have to make it back this NHCO-CH3 to NH2, right? So H minus or HCl, you can H plus you can use. So you'll be getting what? Yes, para bromo aniline. Para bromo aniline. Okay. Yes, this is the reaction para bromo aniline. How will you convert aniline to para bromo aniline? Yes, moving to the next question. Complete the following reaction. Complete the following reaction. So what is this? This is diazonium salt, right? Benzene diazonium salt. So we have studied so many reactions about benzene diazonium salt. All are very important. Okay. Benzene diazonium salt is first treating with what? First treating with HbF4. So what will be the first reaction product? Yes, this Cl2 plus will be replaced by BF4 minus. Okay. And in the next, what will be the product? NaNO2, right? NaNO2Cu. We are adding in the next step and heating. So you will be getting nitrobenzene. So this is the method of preparation of nitrobenzene. Nitrobenzene. Okay. So we cannot add NaNO2 directly. Okay. First step is we have to convert this N2 plus Cl minus into N2 plus BF4 minus by adding HBF4. After that, you have to add NaNO2 and heat. You will be getting nitrobenzene. Okay. Yes. Moving to the next question. Write the structures of A and B in the following reactions. Okay. What is this? This is an acid, right? Acetic acid. Yes. Sorry, benzoic acid. Benzene ring, right? So this is a benzoic acid. We are treating with ammonia, NH3 and heating. So whenever an acid is treated with ammonia, you will be getting what? You will be getting amide, right? So you will be getting CONH2. So this is A. Okay, you are getting amide. So when this is an amide, okay, this is amide. Amide is when treated with bromine in the presence of alkali. Which reaction is that? When you hear the word amide and bromine, just think about Hofmann bromamide synthesis. Bromamide. So bromamide contains bromine as well as amide, right? Amide is here, bromine is here. Okay. And what is the peculiarity of this Hofmann bromamide synthesis? It is also used to synthesize primary amines. Okay. Also used to synthesis primary amines. And one important point is that one carbon less. So amine will be the product amine will have one carbon less than the amide. So here CONH2, right? So in the product, what will be the amine? It will be directly NH2. One carbon less means you have to less the one carbon atom. Okay. Yes, that is this one carbon less than amide. Very important Hofmann bromamide synthesis. Very important synthesis of Hofmann bromamide. So you will be getting amines, primary amines. Okay, primary amines, but one carbon less than the initial amide. Okay. Yes, very good. Next question is very easy. Which of the following is an allylic halide? Allyl. So we should know what is allyl and what is vinyl, right? So whenever there is double bonded carbon, at this position, this double bonded carbon's position, we call it as vinylic position. Vinylic. Okay, vinyl position. So whenever a halogen is attached to this double bonded carbon, it is called as vinylic halide. Okay, it is vinyl position halogen, right? The halogen is in vinyl position. So we call it as vinylic halide. Okay, so whenever a double bonded carbon, there is another next carbon. So this position we call it as what? Allyl position. Allyl position. Okay. So when a halogen atom is directly present in this allyl position, we call it as it is allyl halide. This is allyl halide. Okay. So now see, in the case of first one, you can see double bonded carbon is these two. Okay. These two are double bonded carbon. Here, right? And the double bonded carbon halogen is directly attached. So this is vinylic. Okay, this is vinylic. And in the case of this one, this is double bonded carbon. And to the next carbon, bromine is attached. So this is allyl position. So this is allylic halide. Okay. So this will be the answer. Okay, so you must understand the difference between vinyl position and allyl position. So it is very easy for this question. And you know the correct position. Okay. And move to the next question. Butan 2-on is treated with zinc amalgam, ZnHg, and concentrated HCl. Okay. Yes. So when we see this, just draw the butanone structure. Okay. What is the structure of butanone? Yeah. CH3, CH2, 2-butanone, right? Yes. CH2, C double bond O, CH3. Okay. So, sorry, this is pentanone, right? Okay. Butanone. Okay. C double bond O, CH3. So this is 4 carbon ketone. So this is ketone. CO group is ketone. And this is what its name? Butan 2-on. Okay. 1, 2, 3, 4. And we are taking zinc, ZnHg, in the presence of concentrated HCl. Okay, and what is this reaction called as? Very important. This reaction is called as Clemmensen reduction. Clemmensen reduction. Clemmensen reduction. Okay, so what will happen? What is happening in Clemmensen reduction? C double bond group is converted to CH2 group. That is only the reaction, only thing taking place. Reduction, right? Reduction. C O group is converted to CH2. So what will happen here? CH3, CH2, CO is converted to CH2, CH3. So you'll be getting, what is this? This is butane. You will be getting the butane. Okay, so very simple. Just when you see the zinc amalgam concentrated HCl, that is Clemmensen reaction. Clemmensen reduction will be taking place. Ketones or aldehydes, where if there is CO group, it will be converted to CH2 group. Okay, Clemmensen reduction. Yes. Now, here next question is, 2 molecules of benzaldehyde are treated with concentrated NaOH. Okay. So what is benzaldehyde and what is this NaOH? Only benzaldehyde and NaOH. So what is that reaction? Very simple. What is that reaction? Any idea? Yes, what is that reaction called as? 2 molecules of benzaldehyde are taking. So benzaldehyde has the important property of benzaldehyde is having no alpha hydrogen atom, right? Benzaldehyde is having no alpha hydrogen atom. So you'll be getting what? I'm going to write the benzaldehyde structure. This is CHO and 2 molecules of benzaldehyde, right? Yes, 2 molecules of benzaldehyde is reacting. Okay. And it is treating with NaOH. Okay. So there is no alpha hydrogen atom here. No alpha hydrogen atom. Okay. Lack of alpha hydrogen. Which reaction is taking place? Yes, very important. It's a named reaction, famous reaction. This is Cannizzaro reaction. Cannizzaro reaction. So what is happening in the case of Cannizzaro reaction? Oxidation as well as reduction is taking place. So one molecule is undergoing oxidation, the another molecule is undergoing reduction. So self oxidation and reduction takes place. Oxidation as well as reduction. So you'll be getting what? So when you know this is a Cannizzaro reaction, there is no alpha hydrogen, you must know this is a Cannizzaro reaction. So what will happen? When you write down the product, take one product C6H5COONA undergoing oxidation to form the salt of this acid, and the next one will be undergoing reduction to form an alcohol. Okay, that is the reaction. Okay, understand? Yes. So this is what is happening. Not phenol, CH2OH. Okay, benzyl alcohol. Next, carry out the following conversion. Nitrobenzene to aniline. How will you convert nitrobenzene to aniline? So write down first the structure of nitrobenzene. Yes, nitrobenzene is NO2. So it should be converted to NH2, right? Yes, NH2. So basically this is a reduction process, right? NO2 will be converted to NH2. So you can add the reagents like SnHCl. Okay, SnHCl, or you can add hydrogen in the presence of palladium ethanol. That is also possible. or you can use iron in the presence of HCl. Just a catalyst in the presence of an acid, this reduction process. Okay. And what is the next question? Aniline to phenol. How will you convert aniline to phenol? So aniline cannot be directly converted to phenol. So in the first step, you had to convert aniline to disonium salt, NaNO2 HCl 273 Kelvin. Okay, 0 degrees Celsius. So it will be first forming what? Disonium salt, that is N2 plus Cl minus. Okay, this is disonium salt. And how will you convert disonium salt into a phenol? Very important, disonium salt is converting to phenol by adding water and warming it. Okay, the presence of water, disonium salt is converted to phenol. Okay, very important reactions are, second one is very important. How is aniline converted to phenol? And nitrobenzene to aniline is very simple because O2 is becoming H2. So you know that addition of hydrogen take place, reduction, right? So do that reduction. Okay. Yes. Now next question is, it's a chemical test distinguish between dimethylamine and ethanamine. Okay, dimethylamine and ethanamine. So ethanamine and dimethyl. So let us draw the structures of ethanamine. CH3 is CH2 NH2. And dimethylamine means CH3 NH CH3. Right? So basically, this is a primary amine, right? And this is a secondary amine. Okay. So you have to find a test that how to distinguish between primary amine and secondary amine. So we know the test of primary amines, right? What is the test of primary amines? Primary amine test is chloroform test, right? What is that? Its name is carbylamine test. Carbylamine test. That is primary amines when treated with chloroform in the presence of a alkali, you will be getting what? You will be getting CH3, CH2, NC. What is that? Isocyanide. You will be getting isocyanide, which is having foul smell. So you can distinguish that this is ethanamine. And in the case of secondary amine, no reaction takes place. Okay, does not react with chloroform. Only primary amine react undergoing carbylamine test. Very important test for primary amines. Okay, how will you distinguish primary amine from secondary amine? You can employ this test, carbylamine test, chloroform in the presence of alkali. You will be getting isocyanide, which is having a foul smell. Okay. Yes. Yes. Moving to the last question. Yes. Very simple question. A compound X with molecular formula C3H9N. So we understand that this is a some amine. Okay. We reacts with C6H5SO2Cl. C6H5SO2Cl is what? It is Innsberg reagent, right? To give a solid. Okay. First question was similar to this. Okay, gives a solid which is insoluble in alkali. Okay, so you have to identify X. So insoluble in alkali means what will be that? Is it primary, secondary, or tertiary? Insoluble in alkali means it will be X will be a secondary amine. Okay, let us do the reaction. Yes, CH3 NH C2H5. So 3 carbon, right? Yes, 9 hydrogen. 3, 4, 5, 8, 9 hydrogen, right? Yeah, and then it is treating with C6H5SO2Cl. Okay, Hinsberg reagent. You will be getting a product. What is that product? Yes, C6H5SO2N C2H5CH3. So this product NN ethyl methyl N. So you have to write like N ethyl N methyl benzene sulfonamide. Okay. Yes. And you know that this nitrogen is having no hydrogen atom. It is not acidic in nature. So when you add some alkali, it will get insoluble. So you are getting only precipitate. First step is only taking place. Second step is not taking place. So this is a test for secondary amine Ginsberg reagent test. Okay. Yes. Hope you enjoyed the video. Watch the video. If you like the video, like it, share it, and subscribe our channel. Okay. Thank you so much. We will be meeting in the next video. We will be doing previous year questions. Okay, from next chapters. Okay. So just revise organic chemistry very well. Okay. Bye. Thank you. Have a nice time.